All right, this is the problem that nobody liked in 2016. It confused them, they thought it was weird, and they did a lot of weird things. This is 2016, Calculus A, B, and BC, and this is question number 5. So I'll kind of explain to you some of the issues that students had. So you have a funnel. The height is 10, so I'm going to label that right now. So from top to bottom, it's 10 inches. Do that. Has circular cross sections. So a cross section, basically, as you slice across, you produce circles. So this is going to be a circle. That's all it's saying. The height h of the liquid or whatever's inside is given. The radius r is given, and it fits this formula. So if you know the height, you can find the radius of this funnel. We have inches. Okay, so part A, average value. Actually, this is not something you need to know how to do. You don't have to know average value for this test. But since you guys are such experts and such pros in calculus, I'm just going to do this. My BC kids need to know this, but not you AB this year because of the COVID virus and everything that's been going on. So to find the average of any function, you integrate that function. And in this case, it's the radius. So I will write this out. And divide by the width. So we will do the algebra for that. I'm going to pull the 1/20th, or the calculus, I should say. The antiderivative of 3 is just going to be 3h. And the antiderivative of h squared is going to be h cubed over 3. And 10's a constant. I'll leave 10 down there. And that is going to go from 0 to 10. The last step, I just plug in the 10 and 0 and I stop. I do not simplify. I do not go any further. So that's going to be 3 times 10 plus 10 cubed over 3. And that whole thing is over 10 minus. Now, when you plug a 0 into this will be 0 times 0. So it's just going to be 0. That is my average radius. It's just the average formula. So the volume, this is where it got kind of crazy, because people were like, how do you find the volume? Oh, it's a cone. You take the volume of a cylinder, divide by 3, but it's not a cone. It's curved. So this is where you have to go back to your knowledge and understand. So this goes back to chapter 6. So technically, I guess this won't be tested for AB again this year, but BC kids, you need to know this. So how do you find the volume? So going back to this little disc here, that is a cross section, one little slice. Now, the first one exists down here, and the last one's going to be right around here. And you want to add up the volume of all these discs from top to bottom. Well, how do you add up a bunch of stuff in calculus? I know. It's called integration. And I want to add from 0 at the bottom of the funnel to the top 10. Now, a volume of a disc is the area of the surface times the thickness. So you want to add up area times the thickness. But what is the area of our cross-section? We were told the cross-section are circles. Area of a circle, pi r squared. And the thickness, if you were to look, let's zoom in. You like that, huh? That thickness is a change in y, because as you go up and down, y changes. So that's dy. So, whoa. dy. Okay, we're good. Whew. I was freaking out. And I'm like, whoa, that's not a y. But what is r? We know what r is. We got this. So I'm going to pull the pi out because it's a constant. R is 1/20th. 3 plus h squared, d. Oh, whoa, 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 dh. I'm a liar. My pants are on fire. So vertically, it's not a y. Up and down is h in this problem. So sorry. That's a dh. So the thickness is a dh. That's why we have dh. So let's do some more stuff. So 1/20 squared, it's 1/400. So I'm going to pull that out in front because that's a constant. And if you square this binomial, you get 9 plus 6h squared plus h to the 4th. And now it's a pretty simple process. The antiderivative of 9 is 9h. 6h will be 6h cubed over 3. And h to the 4th is h to the 5th over 5. 0 to 10. Rin 10, 10. That's a win. You just plug in 10, then you plug in 0, and we are finished. That is the volume. So it's going to be 9 times 10 plus 6 times 10 cubed over 3. You might be saying, why don't you reduce to 6/3, make it 2? Because I might make a mistake because I'm not very smart, so I'm just going to leave it like that. And this could be 10 to the 5th over 5 minus, and again, plug in 0 there, there, and there. This could be 0, so bam. We are finito, finished. I am going to cover all this up and give us room to do part D. Oh no, I don't like the color of that outside. Should be white. Oh no, this one. Properties, white. There we go. All right, part C. Oh, by the way, part B, that was a take because you know how we always have those volumes and volumes of rotation and cross sections and area between curves? Well, they stopped giving that question and they incorporated it into other questions. And that was an example of a cross section that you had to recognize. So part C. And so maybe even this coming test, because it's going to be different from past years, there's only 2 of them, they might incorporate a variety of things in one single problem. So be prepared, be prepared for just a real great variety of questions within one question, asking a lot of different topics. All right, part C. A funnel contains liquid that's draining from the bottom. Ooh, I'm going to draw a picture. It's like I picture water, so I'm going to do droplets of water. Bloop. Bloop. Okay. And it says at the instant when when h is 3 inches, the radius is decreasing at the rate of 1/5. I like that. I can write that. So it tells me the radius is changing, dr. As time changes, when h is 3, it's negative. It's decreasing. If something's decreasing, the derivative is negative. And that's inch per second. So that's given. At this instant, they want the rate of change of the height. I know, that is how fast h changes as time changes at that instant when h is 3. Well, to me, this is full-on related rates. We have one rate with an r changing and one with an h changing. So we say to ourselves, man, I wish I had an equation with h and r. I have no clue what it is. I give up and like, oh, wait a second. They gave us one. So cool. So they tell us r is 1/20th, 3 plus h squared. And so as we take the derivative of this with respect to time, r is a function of time. H is a function of time. They're both functions. They're not our variable. Our variable is t. Our variable is t. So when we take the derivative of these, it's with respect to time. So what's the derivative of r with respect to time? Well, by definition, it's dr dt. 1/20 is a constant. I leave that. The derivative of 3 is 0. And the derivative of box squared is 2 times box times the derivative of the box, which is dH dt. Bam. So now I plug in all the known information. So dr dt is -1/5. H is 3. dH dt, I don't know. I will multiply both sides by 20. And now I divide both sides by 6. I'll show you that one. And so what we get is this. Now you can leave it exactly like that. If you choose to simplify, 20 divided by 5 is 4, so it's -4/6 or -2/3. Do they ask for units? Because if they don't, we don't need to put them. It does not ask for units, but you know what? Let's just for practice, let's go for it. Let's put the units. I should have been keeping up with this, shouldn't I? Well, it's height, okay. Change in height over change in time. Height is in inches. Time is in minutes. I believe it was minutes. Yeah, per second, no, second. So it's going to be inches per second. Uh-oh. Inches per second. So that's our units for dH/dt. That's it for problem number 5. Bye.